Hi, welcome to our presentation. We are Denton Space Eagles and we are here to present our private cloud with IoT. First, we'll start with introductions. I'm Mark Yonker.
I'm Shangda Li.
I'm Micah Warren.
I'm Yi Feng.
And I'm Ricardo Garza. And I would like to introduce our project. With NASA periodically sampling sensors for different kinds of use, collection and analysis of the data is becoming more difficult due to the high latency over the connection to Earth. With the wide variety and accessibility of different IoT platforms that can collect and analyze sensor data, there is an opportunity to eliminate high latency problems with one of these IoT platforms. Our objective is to examine an open source IoT private cloud platform and to examine its functionality aboard a spacecraft without a connection to Earth, as well as have test applications to see how the platform would process and handle the data. All the data should be stored aboard the spacecraft with only relevant data being sent to Earth. We will next give a brief overview of our implementation.
For the IoT Cloud platform, we have chosen to use ThingsBoard. To communicate with ThingsBoard devices, utilize HTTP. Telemetry data from the devices is processed through ThingsBoard. Based on received telemetry, if a defined threshold is broken, an alarm is sent out. We developed 4 different test applications to evaluate ThingsBoard's capabilities. Let's start with my application first. The field monitor monitors real-time air pressure, temperature, and the fuel level inside the fuel tank. It has an alert for dangerous fuel status, like high air pressure, high temperature, or running out of fuel. In addition, it can calculate the remaining flight time and distance according to the fuel burning rate and the speed of the spacecraft.
So the health monitor test application is a biometrical data tracker. It tracks the heart rate and SpO2 saturation level of the user, and then the server side will receive the real-time data from the application and update them. The application also comes with a microphone and speaker for communications. An alarm on server side will be raised once the abnormal data present.
The third test application is a weather station. It uses an anemometer, a wind vane, and a rain gauge for measuring rainfall, wind speed, and wind direction. It has a sensor for measuring temperature, humidity, and air pressure. When certain conditions are met, ThingsBoard will send out an alert.
Our fourth application will be a motion sensor camera. Motion sensing has a wide range of uses from automatic doors to floodlights outside your house. We've decided to use it to record any motion detected by a PIR sensor and ultrasonic sensor. Using both in tandem increases accuracy and gives extra data like the distance the object was at. When motion is sensed, the camera is activated and will record and then upload the footage to the cloud. In the cloud, recorded footage will be run through machine learning algorithms using Image AI and perform object detection on the video. Image AI is an open-source Python library with self-contained deep learning capabilities. Once processed, the video will be displayed in the cloud and sent back to the edge to be displayed there as well.
The IoT Cloud platform that we chose, ThingsBoard, has the ability to communicate over several different protocols: HTTP, MQTT, and Bluetooth Low Energy. On HTTP and MQTT, they can communicate over secure means so the data inside will not be intercepted or modified. Once received, ThingsBoard can then process the telemetry from the devices in several different ways, from simple offsets to using other data together to formulate something more complex. It can also analyze that data and send an alert if a threshold is broken. Alerts can be sent through emails, on the dashboards, or send an HTTP packet to another device where it can handle the alert in its own way. And all of this can be done without an internet connection. As you can see here, we have some of our devices sending data to our dashboard that end users can watch. We can go to the rule chains and see the rule chain that starts filtering out all the main data. Some of this is provided already by ThingsBoard for simple operation. And to the right is the stuff that we created so that way the different applications can process their data. Here we can open up applications 1 rule chain and see the different things that were implemented so that way it can process its data. If we go back to the root rule chain, we can see that many of the different applications have their own rule chain so that way they can process the data the way that they need to and perform any type of actions like sending alarms and alerts to users if needed. For future work, teams that continue to work with ThingsBoard, we would suggest looking at implementing third-party analytics, maybe adding GPS on some vehicles and using ThingsBoard's maps for tracking, and even looking into the remote management of devices through ThingsBoard like a smart meter. For teams working on another platform, we would suggest looking at what we've done and comparing it to how ThingsBoard operates.
ThingsBoard's provided rule engine is great for operating on integers, float, or string telemetry. Comparatively, ThingsBoard's support of operating with other types of telemetry force-fed. ThingsBoard allowing development of custom rule nodes helps some, as well as ThingsBoard allowing development of custom dashboard cards. We would like to thank everyone on this list for helping us on the project and helping coordinate this event. Thank you very much. Here are the references that we used. Thank you for watching.